Hello there everyone. Today we will be discussing about solubility and concentration of solutions. So this will be our focus. It will be on the term of solubility. What do you mean by insoluble? What do you mean by soluble? What do you mean by diluted? What do we mean by concentrated? And we will be also discussing about factors affecting solubility. Number one, effect of stirring, particle size, effect of temperature, and nature of solute. So let's continue watching this second part of my video tutorial. Once we say soluble or the term soluble, it is simply because if the particles of the solute are more attracted to the particles of the solvent, then therefore we could say that dissolving occurs. And that's how we define soluble, wherein the solute is said to be soluble in that solvent if dissolving occurs. Now, if not, the term is known as insoluble. So it happens because the particles of the solute are not attracted to the particles of the solvent. Basically, dissolving does not occur. The solute is said to be insoluble in that solvent. Now, this would be a basic diagram for soluble and insoluble. We could see the molecules here in soluble, they are spread apart. Here in insoluble, the black molecules are clumped together and the other molecules uh, are separated. Okay, so meaning to say, this black molecule on the lower diagram, it is insoluble. So basically, some of the solute are insoluble in some solvent. Some of the solute are soluble in others. Let's say, for example, we used to combine gasoline and motor oil. So, gasoline and motor oil is very important for lawn mowers for them to conserve prices of gasoline, because we all know that motor oil and gasoline is quite expensive. So therefore, they will create uh, they will create uh, this solution, okay, to have a cheaper cost. Another thing, we could consider oil and water. So we could expect that oil and water is not mixed up. So they can't be mixed together. Okay, so in this picture we have here the oil. Okay, it flows on the top and the water is below. And one good example for that is an oil spill. Another example for solute and solvent, soluble in insoluble concept is this. We have, for example, chlorophyll. Chlorophyll is soluble in alcohol. However, it is not soluble in water. Now, one principle of solubility is this: if the solute becomes attracted to the solvent. So solute particles are attracted to solvent particles, so therefore they could be mixed up. One example for that is the sugar particles that are attracted to the water particles. Next principle is movement. Mixing causes movement. So when these two substances are mixed, the weak attractions are broken by the motion of the particles. One example for that is we have oil when it is mixed with gasoline, and both have very weak attractions and therefore they are broken by motion. Now, we have here the molecular reason for this. So this is the molecular reason. Now, what happened here? Let's say, for example, we have these sugar particles. It is being placed in water. The water particles pull one sugar particle away from the other sugar crystal. Then, the motion of the water particles carries the sugar particles away. This makes room for one more water particles to move in and pull other sugar particles away. Let's try to watch some animation out of this. Let's play this video. Say for example, this is the sugar particle, and then we put it in water. What happens here is, as the sugar is being added to the water, look at the molecule. The water molecules are able to pull the other sugar molecules away from the crystal sugar. Okay, and then layers of sugar molecules in the crystals are exposed to water, and what happened here is all of the sugar molecules are separated from each other and surrounded by water molecules, and therefore we all know that the sugar is being dissolved. So why some substance do not dissolve? Basically, solute is not attracted to the solvent. Forgive me for the spelling, but this one is solvent. Let's say, for example, we have milk fat particles and we used to dissolve it in water. Will it dissolve or not? So the answer is no, okay? So let's say, for example, this one is the water molecule, the red one, and then the black one is the fat molecule, or the milk fat particles. So fat particles are not more attracted to the water particles, or they are not attracted. So what happened here is fat particles stay together and form insoluble globules in the liquid. Now, this time let's try to define concentration and solubility. This one is the darker T, and then we have the lighter T. We term this darker T as concentrated solution. Why? Because there's a large mass of dissolved solute for a certain quantity of solvent. This one is known as this diluted T, and this is the lighter T, meaning to say there's smaller mass of dissolved solute for a certain quantity of solvent. So, let's try to visualize the example on this side. Okay, we have the diluted, on this side we'll have the concentrated. So therefore, concentrated solution, we could expect more solute particles per unit volume. While for the diluted solution, fewer solute particles per unit volume. So how do we define concentration? It is simply the quantity of solute that dissolve in a certain quantity of solvent. We could describe it first qualitatively, and we could use diluted or concentrated. Or we could describe it quantitatively. Let's say, for example, we have alcohol, which is 10% by volume. So, qualitative, it uses words such as dilute or concentrated. Let's say, for example, the vinegar that we just used in home is just a dilute acetic acid in water. However, for quantitative, we use numbers, and this is very important when safety is an issue. Okay, so we could not just describe vinegar as diluted or concentrated, but rather the vinegar that we just use in home is just 3% acetic acid. So we use numbers. So this time, let's try to define this term, unsaturated solution. This time, let's try to define the word unsaturated solution and saturated solutions. Okay? So, what do you mean by unsaturated, saturated, and supersaturated? So, what is unsaturated solution? Let's have first a definition. It is a solution that can still dissolve solute. Okay? Now, what is a saturated solution? It is simply a saturated solution is a solution that contains as much as solute as will dissolve at that temperature. And what is now a supersaturated solution? So a supersaturated solution is a solution that contains more solute than in a saturated solution. Now, in order for us to understand this, let's try to have this sugar-water experiment. So we will try to define this term unsaturated, saturated, and supersaturated. Okay. So this time, I'll use a sugar and then dissolve it and keep on stirring it. Okay. Now, what we can observe after more stirring? We can observe that the sugar is being dissolved in water. Okay, so this one is an example of unsaturated solution. Next, just try to add more solute and then mix it up. Okay, what happens here is after stirring, and then let's try to look, the resulting solution is a saturated solution because the solution cannot dissolve any more solute sugar. Okay, and then when we add more sugar and then we try to mix it up, we could see that the sugar cannot be dissolved and we could see some sugar crystals out of it. Now, the resulting solution is now saturated. Adding more solute does not dissolve it. However, if you're going to heat up the solution, let's try to heat it up. So upon heating that solution, let's try to observe. The sugar has been dissolved. Okay? Now, if the resulting solution is a saturated solution with no additional solute at a higher temperature, therefore, what will happen here is we try to cool it out and then the heated solution to room temperature. Okay, and then we will try to add more sugar. Okay, no additional solute has been formed so that the solution is known as the supersaturated solution. Okay, so we have this term saturated, unsaturated, and supersaturated. Now, let's try to discuss about factors affecting solubility. What are these factors? The first factor that we're going to have is effect of stirring. So a solute will dissolve more quickly if you stir it. Okay, so meaning to say, before mixture is stirred, this is the movement of the molecules. The solution close to crystal is more concentrated, and the solution farther from crystal is more dilute. Now, we'll try to mix it, and then as the boy mix it up, the concentration is pushed away from the crystal at the same. So meaning to say, these sugar crystals go away from this area, from this concentrated area. So therefore, what will happen? The greater the stirring, the greater the rate of that solute will be dissolved in solvent. Now, particle size. Smaller pieces of solute will dissolve more quickly than larger pieces. So what we can expect? Which one will dissolve more quickly? Okay, so we have here the smaller pieces. Okay, so dissolving a solid in a liquid takes place at the surface of the solid. Okay, and then therefore breaking a large solid into smaller pieces expose more surface, creating a larger surface for which the solvent to interact with. Next, effect of temperature. So as the temperature increase, what will happen? The faster the solute will dissolve. So let's say, for example, we have the hot water and the cold water. That's why we use cold water when making coffee. Now, how about for gases? As temperature increases, the solubility of a gas generally decreases. So adding a heat decreases the solubility of gases. Next, nature of solute and solvent. Now, take note that we are familiar with oil and water, and oil is not soluble to water. So no matter how we're going to shake it, they will not mix up. However, for alcohol and water, when you mix, we can say that alcohol is soluble to water. Now, it depends upon their nature. Higher chemistry will explain this. So this is not the scope of our topic or subject.